I welcome you all in this series of lectures. This is a small effort to share my expertise and knowledge base to you guys. The primary purpose of this series is to guide you about CISSP and to give you the quality content to CISSP aspirants so that they can prepare for the exam. As you all know that there are a total of 8 domains in CISSP. I will go through all the domains and later in the series I will definitely discuss about how to take the exam and tips and tricks of CISSP exam. A quick words about myself. I'm Hassan Imam, information security professional. I have around 12 years of experience in telecommunication, networking, access networks, core networking like routing and switching, DNS, load balancing, and information security. So let's start this domain. Domain number four, communication and network security. So this domain is basically the core domain, one of the core domains of CISSP, and this discusses about how to secure the networking protocols, how to secure network components, and how to secure overall communication. So let's start this domain. So computers and networks or internet basically emerged from integration of various devices. So we have communication devices, storage devices, processing devices, security devices, operating systems, softwares, data, and people. So internet emerged from these integrations. So how these devices are integrated or how integration was possible at the first place. This was because of OSI, that is Open System Interconnection Model. This is an abstract framework, and before OSI model, devices were unable to communicate with each other. Like they have vendors have proprietary protocols, and there was no model. There was no common reference so that they can communicate with each other. So we will discuss in this particular lecture. We will discuss OSI model, and I will try to uh, make the videos for very short videos so that you guys can keep in touch with me and you guys get not bored while listening to the lectures. So communication and network security domain four. This particular domain will discuss about the network components, network devices, and protocols, how they function actually and how they're relevant to security. So, suppose there's a protocol called Routing Information Protocol RIP. This is a layer 3 protocol, and the primary function of this protocol is to perform the routing. So, we'll discuss that how this protocol work, or what is the purpose of this protocol, how routing can be possible using RIP. And we'll also discuss all these protocols, how they function, and how they're relevant to the security. So as you know that CSSP core focus is on security. So you cannot secure a protocol if you don't know how it works. So securing a protocol or securing a technology, you definitely have to understand what protocols are and what is the technology behind that protocol. So regarding book CISSP book, there are two chapters that will discuss about this domain. So it's a chapter number 11, secure network architecture and secure network components, and we have a chapter number 12, secure communication and network attacks. So starting with OSI model, so communication between computers over network are made possible via protocols. So what are protocols? Protocol is a set of rules and restrictions that define how data is transmitted over the media. The media can be anything like twisted pair cable or optical fiber or a wireless media. So protocol is basically a set of rule and restrictions. So you can think of protocol as like a language. Like for example, if I speak English and you guys can speak Italian or French or whatever, so we cannot communicate without a common language. So if I'm speaking in English, you are speaking in Italian, so we both cannot communicate with each other because I am following a different set of rules and you are following a different set of rules. So there's no common reference. So OSI, you can compare OSI model as a language. Okay, this is a language for communication, a language of communication for network devices. Okay, so without a common reference or without a common language, the network devices obviously cannot communicate. In history, basically, When internet was at its beginning stage, there was no such type of model. So there are proprietary protocols. Like if I talk about, there are multiple vendors, and they are unable to integrate with each other. There's no interoperability. Suppose you have Cisco and devices from Cisco, and we have devices from IBM. So devices from IBM were unable to communicate with the devices of Cisco. So there was no interoperability between multiple vendors. So computer of different vendors was so computers of different vendors were unable to communicate with each other. So in the effort to eliminate this problem, ISO jumped in, and ISO is basically International Standard of Organization. They introduced this protocol called OSI model. OSI stands for Open System Interconnection, and particularly it is ISO 7498 that discusses the OSI reference model. So in order to secure a network, it is important to understand technologies, obviously, as I stated earlier. So in order to secure networking protocols, and in order to secure computer communication, you have to basically understand what these technologies are and how they basically function. So in this domain, basically our core focus for focus is basically understanding these technologies, and understanding basically understanding that how we can secure based on the technology. So OSI models is not the first model of interoperability. Before that, we already have another model called TCP/IP model that was developed by DARPA in late 1970s, and OSI model was came into existence in 1980. So OSI model is not the first model, but it got widely accepted by scientists and engineers. However, this protocol was never implemented in actual form. Like the model was TCP/IP that is used in the today's network, but OSI model was never implemented actually in its actual sense. But this model got very widely accepted in by various engineers and scientists, because this OSI model can be thought of as abstract framework or theoretical model for that it describes it how protocol should function basically. So it got a common reference protocol. So for example, if a vendor is going to develop a protocol, like if you are going to develop a protocol, then you have to consult the OSI model. So OSI model got a common reference. So at all the vendors basically follow this OSI model for creating or developing the protocols. So OSI model divides basically the all the networking tasks into 7 layers. So we have 7 layers in this model. These 7 layers are the distinct layers. So every layer has its own responsibility. Every layer is responsible for performing specific functions, and the overall goal is basically to support the data exchange. So how our data is transmitted or exchanged from point A to point B. So each layer is responsible for performing specific tasks or operations. The layers always numbered from bottom to top. So layer one is basically physical. Layer two is data link. Layer three is network layer. Layer four is transport layer, and layer five session. Layer six presentation, and layer seven is application layer. So OSI model is basically a network architecture guide for network product vendors. So and OSI model is a reference point for interoperability. So vendors can ensure interoperability using OSI model. So as I stated earlier, that vendors can always follow or can refer to OSI model for any protocols or for so interoperability is ensured using OSI functionality. So now multiple vendors products can communicate with each other using this model. So there is a term in OSI model called encapsulation and de-encapsulation. So encapsulation is basically the addition of header and possibly a footer. Like as you can see that in this diagram, we have headers at each layer, and in some layers we have a footer. Like in data link layer, we also have a footer. So it depends upon the layer that it will support header or also the footer. So, but the primary purpose of encapsulation is basically to addition of a header or a footer. So, as the message is encapsulated at each layer, the previous layer header and payload combine to become the payload of the current layer. So, for example, if you have a header at layer 6 and if you have header at layer 5, so what will this layer 5 will do? Layer 5 will encapsulate that layer 6 header into the layer 5 header. So it will be the one header. Okay. So it will encapsulate that header also. So this is the process of encapsulation. So as you can see that the application layer from this PC or this PC will generate a message, or the application layer creates a message, and then it will go down to the layer 6, that is session layer, and sorry, the presentation layer, and the presentation layer will encapsulate the message also and add its information in the header section. Similarly, the layer 5 will do, layer 2 will, layer 4 will do, layer 3 will do, layer 2 will do. All the headers and the data will go down to the physical layer and convert it in the form of the bits. And these bits will transfer to the point number B via transmission medium, and where these bits are received at the node number 2 or the point number B. So this process is called the encapsulation, and from the receiving end, there's a process called de-encapsulation. So the receiving computer captures the bit from the physical connection and recreates the message in the physical layer, and the data link layer strips its information and sends a message to the network layer. Network layer will strips its information and it will send it to the transport layer, and slowly and going up to all the layers. The point number B, PC will get the message. So this process called the encapsulation and de-encapsulation. So so we have various mnemonics in this. Like if you talk about the layer 7, at layer 7 we have basically a data stream, and at layer 4 we have basically, we call this packet as segment. We call the stream basically as segment. And at layer 3 we have a packet. At layer 2 we have frames, and at layer 1 we have basically the bits. So this process is called encapsulation and de-encapsulation. So this is basically the interaction of layers in OSI. We have when once in OSI model, basically we have the logical channel with its peer layer. Like we have a device A and we have a device B. This is the sending device and this is the receiving device. So the sender and the receiver will basically create a logical channel with its peer. So as you can see that in lower three layers, physical, data link layer, and network layer, the intermediate nodes are also included, but on the upper layers these nodes are not included. The reason is that the you can say that application, presentation, session, and transport, these layers are basically the application, presentation, session. These layers are the application layers and they are related to the application. So a router which is going to route that information from point A to point B is not responsible or don't care about what application is it, or what is the content of that message. The primary purpose of this intermediate node or this router is to route the information from point A to point B. So it will only strip off the headers of network layer. It will not go above that layer. Similarly, the intermediate node and the other intermediate node will also do the same thing. So it will only strip off the network part, network layer, and it will not see the what's in what the data is contained in the above layers. So the bottom layer is basically the physical layer, and the physical layer is basically responsible for movement of individual bits from one hop to another hop. So this layer basically transmits the individual bits. Okay, so the physical layer accepts the frame from the data link layer, and then it will convert it into the bits, and then it sends it to the transmission medium. And similarly, this layer is also responsible to accept the bits and sending it to the data link layer. So the physical layer contains the device drivers, throughput, synchronization, topology like its bus topology or mesh topology, communication like duplex, full duplex, half duplex, or simplex, These all are the responsibilities of the physical layer. And if we talk about the standards, so we have EIA, TIA, that is for twisted pair cable. So we have these specifications in the physical layer. We have standards like V.24, we have X.21, we have synchronous optical networking SONET at this layer. Um, we have HSSI, high speed serial interface. If we talk about devices, network interface card, hubs, and repeaters, these all devices lie at layer number one. Hubs, the primary function of hub is to basically just send the bits as it is received to the other to the all the connecting ports. Similarly, the repeaters will also do the same, and they will amplify the signal. Suppose to accommodate a specific distance, you can install the repeaters, and repeater will amplify that signal and send it to the medium. So these three devices, network interface card, hubs, and repeaters, are at the physical layer. So through these device drivers and electrical specifications like EIA, TIA, and these standards, the physical layer controls the throughput, and it will also control the rates, handle synchronization, manage line noise, medium access, and determine whether the signal is digital or analog, or how to send it. Like, should I send it into the bits or in electrical form, or should I send it in the light pulses? So these are all are the functions of physical layer. So the next layer is basically the data link layer. The data link layer is responsible for formatting the packet from the network layer into the proper format for transmission, and then it will also responsible to get the bits from the physical layer, and then it will then to send it to the network layer. So the overall purpose of this layer is basically to move the packets from one hop, move the frames, sorry, from one hop to the next hop. So as you know that at layer 2 we have frames, and at layer 3 we have packets. So the proper format depends on the underlying technology, whether you are using Ethernet, whether you are using token ring, whether you are using FTDI. FTDI and token ring are almost obsolete now, and we only have the Ethernet at this layer now. So that format depends on the underlying technology. Obviously there's some specification in Ethernet 802.3, IEEE 802.3 standard. So layer 2 also includes adding source and destination MAC address. So we have a MAC address that is unique to every system, and it contains basically it is a 48-bit address, and the first 24 bits are organizational unique identifier, which defines the organization of which defines the organization or which defines the manufacturer. And the rest of 24 bits are basically the vendor assigned. So vendor can randomly assign it, or obviously they have some format to assign these bits also. So ultimately, the MAC address is basically a unique address that is also called a layer 2 address. And if we talk about the protocols of this layer, we have serial line internet protocol, we have point-to-point protocols, PPP, we have address resolution protocol, we have layer 2 forwarding, layer 2 tunneling protocols, point-to-point tunneling protocols, integrated services, digital network. So all these protocols are basically at the data link layer. We will discuss all these protocols one by one in our after completing the layers. We will discuss each protocol, that what is the function of this protocol, and obviously as I discussed that earlier, that before securing the protocol you have to understand what protocol is and what the technology is. So for now, for today, it's for this particular lecture, I think we should end here, and I will start from the networking layer in our next lecture. Thank you.